Hi everyone, my name is Louis, and I will show you this interesting work about solar flare forecasting. So, the interplanetary space is dominated by several magnetic field topologies that control the confinement and particle flux of the interplanetary plasma. Disturbance in space weather can easily damage communication systems, power distribution, equipment, and satellite reliability. Solar flares, one of the most common magnetic structures in this environment, are eruptions on the surface of the sun with a high concentration of high-velocity particles and intense radiation, usually caused by changes in interplanetary magnetic field. In this work, artificial neural networks are implemented as a method for flare forecasting using long short-term memory models and multivariate time series datasets of sharp parameters. Sharp parameters are is Sharp parameters is a space weather 8NI active ration patch. We use course records of active ration and solar X-ray flare lists between the years 2010 and 2018. In this list, the flares are classified into four classes: B, C, N, and X. Each class is 10 times stronger than the previous one. To create the multivariate time series dataset, the data was downloaded by GSOC for each active ration using the equivalent HARP ID number for the rolling period of active ration. The steps to download data are: the active ration only is in a HARP. The HARP contains only one active ration. The active ration ID or the node number in the HARP record is the same as that in the chorus record, and the location of the active ration is within 68 negative and 68 positive degrees from the central meridian. After that, we slicing using multiple time steps, latence time of 4 hours, and prediction time of 24 hours, and we labeled the time series based in Coast solar X-ray flares lists. We use two outputs. The first is the solar flare C-class in the next 24 hours, and the second is the solar flare M-class or stronger in the next 24 hours. So we get a lot of samples and use undersampling technique to undersample majority cases when do not have any flare in the predicted time and when have only C-class in the predicted time. We pre-processing the data, removing the samples with caps, and we apply normalization between the value 0 and 1. We split the dataset by active region IT using 10% and percent to the test dataset. And we use the model optimization. To the model optimization, we use dropout and class weights. And to performance estimation, we use metrics based on true, false positives and negatives. Here the results. We use the multiple time steps to models with 8, 12, 16, and 20 time steps for hours of observation time. And with that result, it is possible to describe the models obtained as slightly satisfactory results with 17% of recall and 20% of false alarms for C flares in the past model, and 60% to recall with 8% of 8% rate of false alarms for MRX flares. In this case, the active region IT 11889, this active region here, receives 19% for C flare occurs and less than 1% for MRX flares, but had one C flare and no one MRX flares. And to this active region 11890, we received more than 99% for C flare occurrence and more than 99% for MRX flares, with 3 occurrences for each class. Thanks for now, and that's it.